I brought my Yosemite National Parks water with me. National Parks. Yeah, I love Keanu as Keanu in Always Be My Maybe. It's just I don't know, it's a funny bit. Let's talk about understanding organization structure trade-offs. Have you ever looked around your team, your department, or your engineering organization and felt like getting things done is just harder than it should be? Does every project require cross-team coordination? Does every prioritization problem take a long time to resolve? In every organization that I've been a part of, on every team, we felt this at some point. But why is this such a common experience? These kinds of problems can stem from an organization structure that's no longer optimal given the current problems, resources, and missions. All organizations change over time. They grow, they shrink, they pivot. New leaders are hired or emerge. Existing leaders depart. Organizations are constantly evolving. They're a living organism. Organization structures are composed of decisions we make, practices we rely on, communication patterns we subscribe to. And while organization structures may naturally evolve, we sometimes try to hold tight to these structures that no longer meet our needs. Each organization structure has trade-offs baked in, trade-offs that may no longer be right for the next set of challenges. If we recognize that organizations evolve and we evaluate whether the trade-offs are still right for the next phase of our organization, we can choose to reevaluate our structures and evolve them intentionally. Whether we're a CTO, an engineering manager, a senior or staff IC, it is the responsibility of engineering leaders of all types to regularly reflect on the organization structures in their teams and examine if it equips us to tackle the problems ahead. In this talk, we're going to dig in a little bit into organization design, how to evolve an organization, and some trade-offs. We're going to examine Conway's law and try to understand why it's true and how we might harness it. We're going to look at a couple of common options for team structures and consider some trade-offs when thinking through the evolution of an organization. And we're going to look at a practical exercise for understanding your organization's development. By the end of this talk, I hope that you'll agree that while there is no perfect org structure that will magically solve all of your problems with a wave of a wand, we can still evolve our teams to meet the challenges ahead by making the right set of trade-offs with eyes wide open. Hi, I'm Adam. I'm the Director of Product Engineering at semgrep. I serve the engineering and security research teams for our products, semgrep Code, Supply Chain, and Secrets. I love building products from the ground up and helping teams grow. Also, I have a non-traditional background in entry into tech. My undergraduate degree is in philosophy, so I hope you'll excuse a brief dive into some theory. So let's start with Conway's law. You will ship your org chart. Throughout my career, I've heard this phrase tossed around in many different forms, and it kind of feels like trite and like, at this point, kind of meaningless. Flippantly, folks will say things like, if two teams are responsible for a workflow, you'll get a two-part workflow. It's like, okay, what do we do with that information? I think to better understand what Melvin Conway meant, we should look at the actual text, which is not this. An organization that designs a system, designed broadly, will produce a design whose structure is a copy of the organization's communication structures. Conway isn't talking about org charts in terms of hierarchy, or at least not necessarily. Conway is talking about communication paths, and implicitly about friction. Where communication is easy and friction is low, progress is more likely to be fast. Where communication is challenging and friction is high, progress is more likely to be slow. Let's take a step back. Why is this true? We have to think about ourselves as humans. We frequently search for the right path, for the path of least resistance. It can be fun to try something big and challenging. And when we run into blockers, we do our best and we try to go around them. But if we're discouraged too frequently, we may choose an easier path. Building products and building systems is a challenging endeavor. It requires collaboration. We can't really build big things ourselves. When collaborating engineers are on the same team, when they share objectives, when they know how to work well together, that communication burden may be easy to manage, and the results are more likely to be fruitful. When folks aren't on the same team, when they don't know how to work together as well, they maybe have differing priorities, maybe differing objectives, the communication overhead may be amplified, and the results may be harder to come by. But it's worth noting, we say that this is Conway's law. It is not a law. It is not universally true, does not make any guarantees. It's an observation about the way that teams work together. And there are lots and lots of counterexamples. But the observation rings true from my experience. Teams try to reduce overhead and friction. We gravitate toward the simplest model of ownership. And whenever possible, we will produce systems and products that can be singularly owned. How do I know this? In the end result, in most circumstances, the end result in most circumstances is that we ship our org chart. And how do I know this? Well, this is the most literal example I could find. These are the left navigation bars for my current and previous company. And these are the teams at these companies, highlighted in red. Each of these is owned by a single team. So I don't know, maybe I'm the problem. Knowing and accepting that we ship our org chart opens up a lot of possibilities. In the literature on engineering organization structure, folks call it an inverse Conway maneuver, when you design your organization to produce a specific technical or product outcome. If you want 4 microservices, you make 4 teams. But let's start by taking a look at some common team structures. We'll look at 2 examples of organization structures, functional and divisional. Let's start with functional teams. Functional teams are teams that each own a specific technical area. Perhaps the simplest example is a separate front-end, back-end, and infrastructure team, each of which are responsible for building their layer for each of the products. By Conway's law, we might end up with a beautifully crafted code for each system, but business problems that may not be fully solved or might be solved awkwardly because there's no singular owner for the problem. Commonly, though, as teams grow and products take off, we set up functional teams that take on specifically hard technical problems, either so that they can offer some service to other product teams, or so that they can decrease the technical cognitive load that comes from some hard problem and take that off of some team's plate. Conway's law helps us see the trade-off here. In good circumstances, when the API between teams is well-defined, product-focused teams can see a velocity boost since they have complexity taken off their plate, and they can focus more squarely on the business goals. But it's common when forming these teams for the functional team and the consumer team to experience some pain, especially as these teams find their footings working together. There are often periods where the API is yet to solidify or it's changing, or when there are a lot of competing feature requests on the service that the service team has to figure out how to prioritize. In these cases, product teams may not end up integrating the system well or may end up building their own system instead. Let's take a little bit of a look at divisional teams. Divisional teams are responsible for a single product area or feature set. Typically, these are cross-functional teams, and they have all the skills they need within the team to solve their core problems, at least most of the time. When this works well, teams can own their problems end to end, understand the domain context deeply, and solve real business problems. Conway's law helps us understand the trade-offs here again. If teams are sufficiently siloed, they'll spend valuable time and resources resolving the same exact problems. Even if teams are talking frequently, co-owning a service introduces a lot of overhead and coordination and friction. And without a singular owner for a complex service, the service may languish without proper attention. Once we pick a team structure, that structure represents a single point in time. But the team is going to grow. It's going to evolve. It will form fractals, as Evan called out yesterday, and eventually grow into a much more complex system. Different business needs require different team structures. I have yet to encounter an organization that subscribes purely to one of these models of team formation. The art is figuring out the optimal way to blend them together, leaning into Conway's law and understanding the trade-offs. I'll say again, there's no perfect org structure, but the best org structure is the one that serves your purposes with acceptable trade-offs. In this section, we're going to take a look at 2 areas of organization design that require trade-offs: sources of cognitive load and degrees of structure. I'll share my experiences working through these trade-offs as we evolve the product engineering organization at semgrep. Let's start with cognitive load. Cognitive load refers to the amount of information our working memory can process at any given time. So the more cognitive load, the more information someone must be familiar with in order to get their work done. Eventually, the quantity of information becomes really overwhelming, and that reduces the efficiency and the capacity of the team. If one team has to own lots and lots of systems, if one team has to own lots and lots of problems, this makes the team less and less effective. To reduce cognitive load for our teams, we must start by investigating where cognitive load comes from. Two of the most common categories of cognitive load are technical and business domain. So let's start with technical. The more systems a team must understand and make changes to, the more complex those systems, the higher the technical cognitive load. Pretty simple. The more business problems a person must understand on a regular basis, the more domain knowledge they must familiarize themselves with in order to make a change, whether that's multiple user personas, multiple product areas, the higher the domain cognitive load. For most teams, reducing cognitive load means either reducing the number of systems they own or need to make changes to in order to make an impact, or reducing the scope of the business problems they need to understand deeply in order to make their changes. But as teams evolve, the sources of their cognitive load change. Let me share an example. A couple of years ago, I helped start a new product team at semgrep focused on supply chain security. We did like the classic startup within a startup maneuver. We formed a small product team, pulling a cloud engineer, a security researcher, a program analysis engineer from existing teams. And we decided to create this cross-functional, long-lived team in order to accelerate how quickly we could learn about the domain. We repeated to ourselves over and over, build to learn, build to learn, build to learn. And this was okay because technical cognitive load was just not too high. Everyone was an experienced engineer. We were building things scrappily. We had access to platforms and services provided by other teams that took care of a lot of the most challenging technical problems. We had infrastructure platforms set up for us. We had CI/CD. We had cloud features we could plug into. We didn't have to build our own authorization or authentication. We had UI building blocks in place. We had some of the advantages of like being that startup within a startup. And whenever using the platform wasn't easy, we weren't afraid to duplicate systems or build something from scratch, since we expected we'd throw a fair amount of it away anyways. We were in startup mode. We were building to learn. In this case, we explicitly made a trade-off. We traded a narrow focus on a single business problem in exchange for the complexity of a wide array of technical problems, because we knew we were not yet ready to invest in the depth of technical solutions. Even with that breadth of technical problems, it was still pretty shallow. We knew we'd accumulate technical debt in order to learn on the business side. So narrowly focusing on a single product area allowed our team to deeply understand our users and their problems, making it easier for our team to make good choices as we built new features and new systems. But as we gained users, and we built more features, and we scaled our existing features, what happened? The team's technical cognitive load increased. That breadth started to get deeper and deeper and deeper. The scrappy systems we built to learn were now being pushed to their limits. And maintaining these systems with a small team was a large burden. The original trade-off we made, narrow business focus in exchange for technical ownership, exchange for broader technical ownership, that trade-off was no longer appropriate for our context. We had tech debt we needed to address. To decrease this burden required a combination of approaches. So some tactical things we did, we worked with the existing platform teams, making changes on our end so that we could use more of the platform and get rid of our duplicate services. We rebuilt scrappy services that had become criticals. They were easier to maintain, expecting them to continue to grow. And we sunset features that were not useful and not used to reduce our maintenance burden, knowing we were going to build other things instead. We also realized that the technical breadth we needed for a successful product required too many systems for a single team to be responsible for. There was a technical area in particular that required a lot of expertise, security research, that had separate workflows, separate tooling, and keeping everyone on a single team was producing unnecessary cognitive load. Everyone on the team felt like they had to pay attention to what everyone else on the team was doing, but you could kind of notice people starting to tune out what folks who were working on very different kinds of work were doing. It was an unnecessary cognitive load burden we were placing on the team. We realized that by splitting into two teams, engineers could continue to be effective without full context for what the other team was working on. And as our team evolved, the sources of cognitive load changed, and by recognizing this change, we were able to change the structure of the teams to make them effective. In this case, we made a decision with a new trade-off in mind. Splitting out technical complexity helped the team stay more effective, but it introduced a different trade-off: coordination overhead on cross-team work. In this case, we were willing to pay that cost because it turns out there weren't that many projects that required input from both teams at the same time, and the teams had a lot of trust already built together, so people knew how to bridge those gaps. As we figure out how to tackle new problems, we might be faced with a decision on how to evolve our organization structure. We might change that structure of an existing team, or we might choose to spin off new teams. But understanding the sources of cognitive load in your organizations will help you make those right sets of trade-offs. Let's turn our attention to a second area that requires trade-offs: degree of structure. As we build our organizations, we put in place a certain amount of structure, but how much structure ends up making a really big difference. On the one hand, we want to be resilient and robust, like the armadillo. We want to look ahead, we want to plan for the future, we want to grow and hire in an intentional way. We want long-lived teams that have the skills and domain knowledge and trust to build amazing systems and solve business problems completely. On the other hand, we want to be flexible and nimble like the octopus. We want to be adaptable enough to pivot. We want to be able to make decisions and solve problems quickly. We want to hire great people. We want to let them find problems and solve them without red tape. Finding the right balance between structure and flexibility is really hard. As the semgrep supply chain team grew, we once again had to change our trade-offs. In the beginning, the team was super flexible. We were full in octopus mode. We didn't have stand-ups or sync meetings or really any operating rhythms of any kind. We were working together every day, jumping from problem to problem, kind of doing the thing that people talk about where you like lock your team in a room, stay super focused, everyone in it together. And we had no real structure other than our areas of expertise. Everyone was invited to every customer interaction. People self-selected how they would spend their time, and we really trusted each other to make good choices that would further the product. In this case, we really flew by the seat of our pants, but that was okay. We were trying to learn as quickly as possible. And so we built scrappy systems that would help us experiment and collect the next set of feedback. We would fail fast, and then we'd throw away many of these systems, and these systems that were no longer useful for the next experiment, so we didn't really have to worry about long-term ownership. And we were okay with this explicit trade-off. We traded flexibility for a lower degree of technical ownership. But eventually, flexibility started to cause problems. Octopus became frowny face. Everyone co-owning everything meant staying familiar with everyone's work. And staying familiar with everyone's work was becoming a full-time job for everyone. We've heard a lot about burnout. This was a cause of burnout. We weren't fastidious about writing things down, so missing a discussion set folks back. As our team cognitive load increased, our level of flexibility was amplifying the problem. It was clear that this level of flexibility was unsustainable. In order to meet the next set of challenges, our organization had to evolve. As we talked about earlier, we split out a complex technical function into a separate team. In a vacuum, this could have been a disaster, but we also coupled it with an evolution in how our team thought about structure. We realized that the degree of low structure we were used to was no longer serving us. We agreed to try out a slightly more structured approach, including more regular planning meetings, regular async stand-ups, an increased level of documentation, and regular opportunities for the team to share work across team boundaries. We explicitly traded away some of our flexibility here in exchange for structure that would clarify ownership and increase the ease of knowledge sharing at scale. I wouldn't say we were full armadillo mode, but our octopus had learned a few lessons from our armored friend. As your organization changes, you must figure out how structure or lack thereof serves your needs. Flexibility can grease the wheels of innovation and iteration, but unbounded flexibility can become a source of friction as the team evolves. As the demands of your team change, different levels of structure can help you optimize for the problems ahead, whether that is learning as quickly as possible or building robust, long-lived systems. These are a few examples of the trade-offs that you should consider as you think about the next evolution of your organization. In this last section, we're going to share a practical exercise you can use to help identify the implicit trade-offs you're making with your organization design. We're going to start by, in this exercise, we're going to go through a 3-stage progression to help us think abstractly about our organization. We're going to start by identifying the problems we're responsible for. We'll group those problems into logical groupings that could be owned by a team, and then we'll examine the roles of each theoretical team. We'll examine the roles that each theoretical team would need to be successful. First, let's identify the problems that we're responsible for. Start by writing down the problems your organization is responsible for. That seems like an easy step. A colleague of mine showed me this tool, MindNode, that helped me map this out for my teams. Previously, I used spreadsheets, but this is a free tool. It's really useful. This is a simplified version of the one we built for my organization. And you may want to do this for both business problems, as I did here, and then also technical problems on the other side. In this case, we want to start from problems instead of people in order to help us decouple these problems from their current owners. To build this list properly, you're going to need inputs. And you can start from your own knowledge. And you may have some tools, maybe ticket tracking systems or service catalogs that can provide helpful data. But I encourage you, it's really helpful to supplement this by asking folks in your organization directly. What do you own? What do you feel responsible for? There are probably things that are slipping through the cracks. And most likely, they're going to know the problems and those intricate details better than we do. You might also get feedback from peer teams, PMs, customer support to help build a more exhaustive set. Maybe they think you own something, and you don't quite agree. OK, let's talk about grouping these problems. These groupings are theoretical teams, possible configurations of ownership. Try grouping these problems according to a bunch of different criteria: shared technology, similarity of workflows, product area, user persona. You may find that some problems are easier to group than others. Maybe some stand out by themselves, and it's really hard to group them with any others. You may find also some common dependencies or problems that are relevant to multiple teams, and you might be identifying a future service team or platform for the future. Pause for a bit and reflect on how these theoretical groupings differ from your existing team structure. What are you optimizing for in your existing structure? What trade-offs are you implicitly making? If you wanted to make a different set of trade-offs, how would you start? Another angle to think about: how might you share context between these teams and reduce cognitive load, but without forming a new team, which can be really expensive? Some considerations that might help you answer this include, like, how does your organization just share knowledge in general? Do you have technical guilds? Do folks rotate between teams in order to share knowledge and share skill sets? Do you have a culture of lunch and learns or other means of sharing technical or business context? Finally, map roles to teams. In this exercise, this doesn't mean specific people in your organization. Instead, take a more headcount planning view of these teams and think through the roles, skills, seniority, and context that each team would need to be successful. Again, look at our existing teams. How are our existing teams different from this breakdown? What trade-offs are you making here? Do you have enough leaders in your organization to take on new problems as they arise? Have you built a leadership bench that can help you with that? Is technical and business context shared widely enough to give the organization flexibility? At the end of this exercise, you may notice some gaps, maybe some differences at various phases, and that's OK. We've made trade-offs before, and we'll make trade-offs again in the future. By understanding these gaps, we can begin to mitigate some of these pains and evolve the organization. And because organizations are constantly changing, we're going to have to adapt anyway. As you plan ahead for the future of your organization, remember, there's no perfect org structure that will magically solve all of your problems. But through regular reflection and deep understanding of the business and technical problems, we can make good trade-offs and continuously evolve our org to meet the challenges ahead of us. Thanks so much.